Welcome back to our Arduino series. In the previous video in this series, you learned about the basics of arrays. In this video, I want to show you a slightly more advanced example of using arrays to work with lots of data. This Arduino C++ script stores the last 10 floating point numbers from a simulated sensor and then prints the array's contents to the serial monitor. I'm using a simulated sensor because I haven't yet shown you how to use a real one. We'll get to that later in the series. A simulated sensor is a technique you can use anytime you want to work on a programming problem without the overhead of dealing with the hardware. The objective is to solve the programming problem first and add the hardware when it's done. In our case, the hardware would be an environmental sensor that outputs the temperature as a floating point number. Let's have a look at how this program works. In lines 1 to 8, we initialize constant and variables, including the size of the array called array size, the array itself called sensor readings, and an index variable called current index, to keep track of the current position in the array where the next value will be stored. In lines 10 to 13, we have the setup function, where we start the serial communication with a baud rate of 9600, which is standard for Arduino projects. In lines 15 to 41, we have the loop function, which simulates reading a sensor value, stores this value in the array, prints all values in the array to the serial monitor, and then waits for 1 second before repeating the whole thing again. This function demonstrates using an array as a circular buffer to store the latest readings. In line 17, we simulate a sensor reading. In a real project, this would involve reading from an actual sensor. The analog read parenthesis A0 times 0.1 is a placeholder for sensor data conversion to a floating point number. We multiply the reading from analog pin 0 by 0.1 to get a floating point number to store in the float array. Why is this random, you might ask? Well, because there's nothing connected to analog pin 0, this pin is considered floating. The term floating means that the voltage of this pin can fluctuate randomly. As a result, a floating analog input pin is considered an acceptable source of randomness in the Arduino for the purpose of this example. However, I should point out the following. First, a floating pin is susceptible to electromagnetic interference and noise from the surrounding environment, including the internal workings of the microcontroller itself. Second, as a result, the values read from a floating analog pin can appear random and change rapidly over time. Still, they are not random in a way that would make them suitable for cryptographic or scientific applications requiring true randomness. The values are more accurately described as noisy, reflecting the various disturbances the pin picks up. For applications requiring true random numbers, it's better to use a dedicated hardware random number generator or algorithms that can produce cryptographically secure random numbers, bearing in mind that implementing such algorithms on microcontrollers like in the Arduino Unos presents its own challenges and limitations. Let's continue. In line 20, we store the new sensor reading in the array at the current index position. In lines 23 to 28, we increment the index to point to the next position in the array. If the index reaches the end of the array, called array size, it's then reset to 0, making the array work as a circular buffer. Lines 31 to 36 iterate through the array and print each sensor reading to the serial monitor, formatting the output for clarity. In lines 39 to 40, we add a delay of 1 second to slow down the loop iteration, making the serial output easier to read, and we print out a separator line for clarity. This example is a good starting point for understanding how to use arrays to store and manage data from sensors or other inputs in Arduino projects. I hope you've enjoyed this video. I'd appreciate a thumbs up, and I invite you to subscribe for more Arduino tutorials if you haven't done so yet. Drop your questions and ideas in the comments below. Happy coding, and see you in the next video.